Okay, the last big focus for dealing with radicals, I would say to prepare for the calculus that I wanted to go over. So we call this part 3 of 3 is going to be related to domain restrictions. And so from the first radicals video, the part 1 that we did, we were talking about how you cannot take even roots of negative numbers in the real number system. So just a reminder of that, if we want to find the domain, those are all the values that x actually can be in the function. And we have the nth root of x, where n is going to be an even whole number. All we really need to do is find out when what's under the radical, the radicand, is greater than or equal to 0. So we just need to solve when is x greater than or equal to 0. So these are the few examples that I have up here that we'll work through. So for the first one, if we want to find the domain, the radicand is just this part, x minus 5. So we will just take the x minus 5 and solve the inequality when is that greater than or equal to 0. So we add 5 over to both sides, and we see that x will have to be greater than or equal to 5. So in interval notation, we will just write that like so. And so the domain here would be any number that is 5 or greater, right? Because if you put in 5, well, you can take the square root of 0. That's defined. That's 0. Any number larger will keep that radicand also positive. So the same concept is going to go for all of these. They just present a little different. So for example, with this one, all right, if we want to solve this, this is saying when is 9 minus x squared greater than or equal to 0? And this is a quadratic inequality. We can rewrite it and put it in standard form. And if you divide everything by a negative, we would flip the sign. And so it would look like that. And if you remember the way to solve these, you can do like a few step process by making a little number line and doing a number chart. But first you want to find out where this actually equals 0. And so we would factor this. And you can see that it's going to be 0 at 3 and -3. But then now we want to find out where it's less than in this little step. So that's when it's negative. And so you can do a little sign chart and test. But your answer is going to come out to be any value that's going to be in between -3 and 3 will make this true. So we are going to just write our answer like that. Okay, so the domain of this function would be between -3 and 3. And you can see that if you put 3 or -3 in there, you're going to get 0. And if you put any number in between, that still keeps the radicand positive. For example, if you put in like 0, 9 minus 0, square root of 9, that's still going to be positive. Now let's look at the third example down here. The only difference with this one is the radical is placed in the denominator, which means it's going to have to the radicand is going to strictly have to be greater than 0. So instead of solving x plus 2 greater than or equal to 0, we're just going to solve x plus 2 greater than 0. And so this time we're going to get x has to be greater than -2. Because if we put a -2 here, we're going to have the square root of 0, which normally is fine, but not if you have 1 over 0. That would be undefined. So this one's domain would just be from -2 to infinity, and we would not include the -2. And then the last type of example we'll look at is a combination of functions where you have two radical functions, but they're added together. So what you would need is both radicands would have to be greater than or equal to 0 at the same time. So not only would you need this one to be greater than or equal to 0, but you would also need this one to be greater than or equal to 0. So here we have that x is going to have to be greater than or equal to 1. And this one, you could subtract the 4 and then divide by a -1, which will flip the sign. And you have x is going to have to be less than or equal to 4. So you need to be both at the same time. So if you want to put this on a number line, greater than or equal to 1 would look like that. However, less than or equal to 4 would be the other way. And so if you need to be both at the same time, it's really just this middle part in between there. So the domain here would be every value between 1 and 4. But you could also include 1 and you can include 4. So this would be the answer for that one. So these are a couple different scenarios just to practice making sure that you can find the domain of a radical function. And remember, it only really applies to even radicals because you can take odd roots of negative numbers. So those would have a domain of all real numbers. So we just really have to watch out for the even roots. So keep practicing.